Welcome. The topic today is linear motion, and the question we have, the diagram below shows the speed time graph for a bus traveling between two towns. The bus starts from rest and accelerates uniformly for 50 seconds. It then travels at a constant speed for 150 seconds and finally decelerates uniformly for 100 seconds. So the graph is as shown. So given that the distance between the two towns is 2,700 meters, calculate the maximum speed in kilometers per hour the bus attained. In part B, acceleration. Part C, the distance the bus traveled during the last 50 seconds. And D, the time the bus takes to travel the first half of the journey. To begin with, we want to determine the maximum speed in kilometers per hour. So the graph we have here describes the motion. So according to the question, we are told that the bus starts from rest. So it starts at rest, and then after 50 seconds it accelerates. So this shows acceleration. So the speed increases steadily up to some point. So that takes place in 50 seconds. So we are going to have down here 50. And then after that, it then travels at a constant speed for 150 seconds. So from this point here, the speed is not changing, so it's constant for some time up to that point. So that we're told takes 150 seconds. So 150 seconds added to 50, that should give us 200. So at this particular point, we have 200 seconds. And then finally, it decelerates uniformly for 100 seconds. So it decelerates to mean from maximum speed, it will decrease up to 0 when it stops. So at this particular point, it is decelerating, and this takes place after 100 seconds. So add 100 to 200, so here we have 300. So there's this maximum velocity attained. So when it was accelerating from 0 to this point, it attained the maximum velocity at that point. So this is what you're looking for in part A. So usually in a velocity time graph, distance is usually calculated by getting the area under the graph. So here, the distance already we are given, and what is missing is the maximum speed. So the speed should represent the height of this trapezium that we have, because for us to calculate the total distance traveled, we need to get the area under the graph, of which the shape here is a trapezium. So distance is given by simply having a half times the height. So this is the formula for calculating area of a trapezium. So it's a half times the height, and the height for this case is the velocity v, into the sum of two parallel sides. From 0 to 300, we have 300 seconds, plus from this point to this point, we have 150 seconds. So we get the difference between 50 and 200. And you're told that this distance is already 2,700 meters. So from this equation here, we'll be able to get the value of v. And for this case, you are going to have, so this is 450 over 2v is equal to 2,700. So multiplying both sides by the reciprocal of 450. So we're going to have this side B, which should be equivalent to, and then multiplying this should give us 12 meters per second. So that the maximum velocity in meters per second is 12 meters per second. But we are asked to calculate the maximum speed in kilometers per hour. So in kilometers per hour, that will be 12 meters per second times 18 over 5. So this calculated should be 43.2 kilometers per hour. So that's for part A. For part B, we are required to get the acceleration. So between 0 and 50 seconds, we have acceleration. So we're going to have acceleration, the final velocity minus initial velocity, all over the time taken. So after 50 seconds, we realize that the final velocity is the maximum velocity attained. We'll have it in meters per second. So that is 12 minus the initial velocity was 0. So it was beginning from rest. And then the time taken was 50 seconds. So with this, we'll be able to get acceleration as 12 over 50, and that simplifies to 0.24 meters per square second. Then next, we are supposed to be calculating the distance the bus traveled during the last 50 seconds. So during the last 50 seconds, we have this. So at this particular point, we have the velocity as 12 meters per second. And then between this point here and this point here, the time difference is 100 seconds. So after 50 seconds, so that is half that time. So after 50 seconds, we believe that it will be somewhere here. And the point is 250 seconds. So that after 50 seconds, the velocity has reduced by half. So that at this point, we have the velocity at 6 meters per second. So you're going to have the distance the bus traveled during the last 50 seconds by simply calculating the area under the graph within those particular times. So we have between 250 seconds and 300. So that is the last 50 seconds. That means you're going to get area under this triangle. So what we'll simply have is I have the base times height. So that is the area, which is also the distance. So the distance is given by distance is a half times the base, and the base should be 50, and then the height will be 6. So we're going to multiply a half times 50 times 6, which is 150 meters. And then finally, the time the bus takes to travel the first half of the journey. So what we're going to do here, we'll assume that in half the journey, the bus has traveled this particular distance by simply having the time taken as 0 to 50 plus this time here is not known, so we need to determine this time, which is also the same as up there. So the total time taken will be between 0 and this point, that is 50 plus x. So that is what we want to determine. So we're going to get the area under the graph within that particular time, and then from there we'll be able to determine the value of x. So we have the time the bus takes to travel. So we use the formula distance traveled in half the journey, which is just area under the graph, which is a half times the height. So we are getting this area, a half times the height is still the velocity, times the sum of two parallel sides, x plus 50 for this particular side. So we're going to have a half times velocity, which we already obtained as 12 meters per second, into one of the sides is 50 plus x, and the other side is x. And we are told that it is half the journey, so that is a half of 2,700. So the total distance was 2,700. So we are covering just half of the distance, and that should be 1,350. So this should give us 6 into 50 plus 2x, which is 1,350. So we have 300 plus 12x is equal to 1,350. And from here, we can also say 12x is equal to 1,050. So 300 crosses, we subtract to get this, and then dividing both sides by 12 mean that x is 87.5. So the time taken should be 50 plus x. So that is from here, from this point to this point is 50 seconds, and the another time required so that we cover half the distance is x. So this x we've already determined as 87.5. So the total time taken for half the journey will be 50 plus x. So let's add 50 to the value of x we obtained, and that is going to be, so the time is 50 plus 87.5, and that should be 137.5 seconds. So that's it for this question. Thanks for your patience. See you next time.